Good morning, students. Welcome back to science class on the chapter light. Yesterday we had discussed the refraction of light. First, we had studied what is a reflection of light. So, refraction of light means the bending of light when it travels from one medium to another medium. Okay. So later we discussed the laws of refraction of light. The first law it says that incident ray, normal, and refracted ray all lie in the same plane. So next second law it states that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for a given two pair of media, which means if you pass a rays of light at different angles, at last if you take the ratio of sine I to the sine r, then you will get a constant value. So that constant is called a refractive index. Refractive index. Okay. We have studied the reflection of light through a rectangular glass slab. Okay. So just imagine this is a rectangular glass slab. I am passing a ray of light. Okay, incident ray, and at the point of incidence, we draw normal. That normal is perpendicular to the surface, and it bends. So now here, air medium to glass medium. So this is a rarer medium, and this is denser medium. I will call this medium as 1 and this medium as 2. Okay, so now I am passing a ray of light from rarer medium to denser medium. Here, the speed of light it decreases, so that's why it bends towards the normal. It bends towards the normal. So this is angle of incidence and this is angle of refraction. Okay, so this is A, O, and this is B. See, so now this is incident ray, this is the refracted ray. Next, once again it strikes here, right? So once again it undergoes refraction. So now see initially that light it will travel from rarer medium to denser medium. So now here, so once again that light is traveling from denser medium to rarer medium. So now here the speed of light decreases. So now here the speed of light increases. Why? Because here the ray of light traveling from denser to rarer. So that's why it bends away from the normal. It bends away from the normal. Okay. So this is also angle of incidence, this is also angle of refraction, and we call this ray as emergent ray. Okay. So now say this is BC. This BC line is the emergent ray. And one more thing, see this is the actual direction of the light. Okay. See here, the light ray bends. Why? Because here we have kept glass slab. Okay, so that's why that ray it bends. So now listen here. Here, this is the actual ray, and this path and this emergent ray both are parallel to each other. Okay, this is the actual direction of the light, and this is the emergent ray. Both are parallel to each other. Okay. Uh, Next, move to refractory index. So this is air medium and this is glass medium. So I will call this medium as medium 1 and this is medium 2. Okay, I am passing the ray of light. bends towards the normal. Okay. Uh, See, the refract index means the extent of the change in the direction that it takes place in a given pair of media can be expressed in terms of refractive index, which means just imagine this is array of light traveling from medium 1 to 2. Okay. Now, see, I will write this as n to 1. Okay, see here n to 1, which means a ray of light traveling from medium 1 to 2. A ray of light traveling from medium 1 to 2 is equals to V1 divided by V2. Okay, so V1 divided by V2. Here n means refractive index. Here n means refractive index of the second medium with respect to medium 1. Listen here. Here V1 means speed of light in medium 1. V2 means speed of light in medium 2. Okay. So now here if you write like this n to 1, so which means the speed of ray of light traveling from medium 1 to 2. Then if you write like this 1 2, which means ray of light traveling from medium 2 to 1. Okay. So here n means refractive index of the second medium. Here a ray of light traveling from medium 1 to 2, right? If you take the ratio of speed of light in medium 1 divided by speed of light in medium 2, then you will get to one value. So that value is the refractive second medium. Okay, then what is the refractive? See, refractive index means, the speed of light is here. Just this is air medium, right? In air medium, the speed of light is 3 into 10 raised to the power 8 meter per second. Okay, see, actually this is the speed of light in vacuum, but in air it is a little bit less, but it is very close to 3. So in air medium also, while calculating, we will take the speed of light in air medium also 3 into 10 raised to the power 8 meter per second. Okay, see here, in air medium the speed of light is 3 into 10 raised to the power 8 meter per second. But what about when the ray of light enters into the glass medium? Do you think that the speed of the light remains the same here? No, right? See, the speed of light here decreases, so that's why it bends. Okay, so here how many times that speed of light decreases in a glass medium? Okay, so that gives the index. For example, listen here while doing this one, you will get answer. Just imagine, you will get 1.5. Okay, 1.5 by doing this. So here you have entered speed of light in medium 1 and speed of medium 2. So after dividing, you just imagine, you will get answer 1.5. Okay, so now this 1.5 is called a refractive index, which means the speed of light in the glass medium 1.5 times lesser than the speed of light in air. Okay, so here the 1.5 means, or we can say that the speed of light is 1.5 times greater than the speed of light in glass medium. So, okay, so this is called a refractive index. See, refractive index means here, see, now this is the refractive index of the second medium. Okay, refractive index of the second medium, not first medium, because I am passing a ray of light from medium 1 to 2. Okay, so here you have taken the ratio of V1 divided by V2. So just imagine we got answer 1.5. Okay, so this 1.5 is the refractive index of the glass. Refractive index of the glass. Okay, just imagine now I will pass a ray of light from medium 1 to 2. Okay, so I will write on here. So this is medium 1, this is medium 2. Okay. Now see here. Here our ray of light is traveling from medium 1 to 2, and here medium 2 to 1. So now here we can write this formula, this expression as N12 equal to V2 divided by V1. See, it's here. Now here our ray of light traveling from medium 2 to medium 1. So that's why the speed of light in medium 2 divided by speed of light in medium 1. So now here this is the refractive index of medium 1. Okay, so now this n here, this is the refractive index of medium 1, and here this n is the refractive index of medium 2 with respect to medium 1. Okay, so this is called the refractive index. See, refractive index means simple. How many times the speed of light, whether it is slower or faster than the respective other mediums, whether it is air or vacuum, whatever it is. For example, say I am passing a ray of light from X medium to Y medium. I don't know which medium this is. Okay, I am passing a ray of light from X medium to Y medium. Okay, so here you will do the same thing. Then you will get answer say 1.3. Okay, by taking ratio and here you get answer 1.3. But you are passing a ray of light from X to Y. So now this 1.3 is the refractive index of the Y medium, which means the speed of light in X medium is 1.3 times greater than the speed of light in Y medium. Okay, or if you take see, now this is water medium and this is glass medium. I am passing a ray of light. Okay, so this is medium 1 and this is medium 2. Now I am passing a ray of light from medium 1 to medium 2. So here also we can write N to 1, which means a ray of light traveling from medium 1 to 2 is equals to V1 divided by V2. V1 divided by V2 means the speed of light in water medium, I will take it as V1, and speed of light in glass medium, I will take it as V2. Okay, V1 means what? Speed of light in medium 1 and speed of light in medium 2. Okay, so while doing this, you will get one answer. Okay, so just imagine 1.6 or 1 cent, take 1.4. Okay, so now this 1.4 is the refractive index. Okay, the refractive index of the glass medium or medium 2 with respect to medium 1. Okay, so or we can say that the speed of light in water medium, the speed of light in water medium that is 1.4 times greater than the speed of light in glass medium. See, I am taking just example. Okay, just I am taking example. So here, or we can say that the speed of light in glass medium is 1.4 times slower than the speed of light in water medium. Okay, so it's a very simple. In glass medium, the speed of light 1.4 times slower compared to speed of light in water. Okay, so this is called refractive index. Okay, suppose now I will pass a ray of light from here, from water to glass. Sorry, from glass to water. Okay, so now here we can write speed of light is 1 here. The speed of ray of light traveling from medium 2 to 1 here, then speed of light in medium 2 divided by speed of light in medium 1. So here also you will get one answer. Just example say 1.3. Okay, 1.3. So here we can say that this 1.3 is the refractive index of medium 1. Okay, this 1.3 is the refractive index of medium 1 with respect to glass medium. Okay, see the refractive index which gives how many times it is slower or faster than the medium. Okay, so next move to absolute refractive index. Okay, absolute refractive index. So absolute refractive index. Here, in absolute refractive, here you have to consider one medium as air or vacuum. Okay, why? Because in air and vacuum, the speed of light is that is 3 into 10 raised to the power 8 meter per second. Okay, this is the speed of light, which is maximum in air and vacuum. Okay, so here you have to consider one medium as air or vacuum. Then second we can consider any medium, for example, water, glass, diamond, whatever it is. Okay. This is medium 1, this is medium 2, and this is air or vacuum, this is glass medium. Okay, and then we can write expression Nm is equals to C by V. C by V. See, you can use here also, you can use this one. Okay, that N2 one, both are same. But here, if the one of the medium is here air or vacuum, then we use this formula. Here, N means refract index of the medium. Refractive index of the medium. Here C means speed of light in air or vacuum. Here C means speed of light in air or vacuum. Then V means speed of light in this medium, whether it is a glass or water. So now here it is glass, right? So here V means the speed of light in glass medium. Okay. So this is the formula for absolute refractive index. Okay, here we should consider what one of the medium as air or vacuum. Okay, and in your textbook they have given page number 85. Okay, that is a table 10.3 absolute refractive index of some material media. See here, air 1.003, then ice 1.31, 1.31, then water 1.33, then alcohol 1.6, 1.6, then kerosene 1.44. Okay, here they give so many refractories of the media, so I write few. Diamond is 2.42. 2.42. Okay, see these obtained obtained by considering one of the medium as air or vacuum. Okay, see here, here air medium is speed of light in air medium, the speed of refractness of the air medium is 1.003, which means here they have considered this is a vacuum, this is air medium. Okay, air medium. Okay, so here the refractive index we got 1. Why? Because the speed of light in the air medium is very less, so almost equal to the speed of light in vacuum. So that's why while taking the speed ratio of speed of light in the V1 and the speed of light in V2, so we got 1.003, or we can write sorry C by V. The speed of light in vacuum and speed of light in air medium. Okay, so we got answer 1.003, so which is approximately equal to 1, and this is the refractive index of the absolute refractive index of the air medium. Next, ice is 1.3. Here You consider speed of light in vacuum, and this is ice. Okay. So now we're taking the ratio of speed of light in vacuum divided by speed of light in ice. Here V means speed of light in ice. So here we got answer 1.31. So this 1.3 is the absolute refractive index of ice with respect to vacuum, or the meaning. So here the speed of light 1.3 times slower than the speed of the light in vacuum. Clear? See, it is very simple. 1.3 times it is slower. The speed of light decreases. Okay. Next, this is water 1.33. Here the speed of light in vacuum. Just imagine this is a water medium. Okay, water medium. So here you get answer 1.33. Okay, the speed of light in water, that is 1.33. Here also we can say that the speed of light 1.33 times slower than the speed of light in air or vacuum. Next, alcohol, that is 1.36. 1.36. So here also we can say that the speed of light 1.3 times slower than the speed of light in alcohol. If you take a kerosene 1.4, the speed of light is 1.4 times slower. The speed of light 1.44 slower than the speed of light in vacuum. Okay. Hope you got what is the refractive index. See, these values are called absolute refractive index. Okay, here because we should consider one medium as air or vacuum. Okay, see, if we consider one medium as water and the second medium as glass, then we won't call this as absolute refractive index. If you want to call absolute refractive index, then we have to consider one medium as air or vacuum. Air or vacuum. Okay. Suppose in an exam, when asked, they will give two mediums. Okay. For example, X and Y medium. The refractive index of X medium is 1.5 and the refractive index of Y medium is 1.3. Maybe they'll ask out of these two, in which medium the speed of light travels more? Okay, so clearly we can say that is medium Y. If the refractive index increases, then its speed of light decreases. Okay, if the refractive index of the medium is more, then the speed of light decreases more. Okay, so here the refractive index is 1.5 and this is refractive index of 1.3. So out of these two, we can clearly say that the speed of light in air medium is, sorry, in Y medium is more. Okay, or the speed of light in Y medium is more than the speed of light in X medium. Okay. So next move to refraction by spherical lenses. Okay. In a lenses also there are so many types are there: plano, concave, convex. Okay, but this year we are going to study only two lenses. Okay, those are, first one is convex, then second one concave. Okay, concave lens. Okay, lenses. First one. So just take two circles. Okay, just take two circles. Join both the circles like this. Okay, So just here. So now, so listen here. This portion, it is a part of this circle. I call this C1 and this is center C2. Okay, and this portion is a part of this side circle. Okay, so if you use completely like this, then it will become a convex lens. What is that? Convex lens. Okay, and the center part, the center point of the convex lens is known as optic center. Is that optic center? Okay, so now this is convex lens. Next, see here. Now take once again two circles. If you go like this. Okay. See now, see here. This is a part of this side circle and this is a part of this circle C1, C2. So then it will become a concave lens. Okay, concave lens. Draw here clearly. Concave lens. Okay, here also the center part is known as optic center C1 and C2. Okay, so we call this as optic center. Okay, just imagine here it looks just like a cave, right? Here you come here, so that's why remember that one. Okay, don't confuse. It's just like a cave, so that's why we call it as a concave lens, and this is convex lens. Okay. Suppose if you pass a rays of light to concave and convex lens, what happens? How the rays are refract? See, these are made up of glass, not mirrors. Okay, so that's why we call these are lenses. Okay, you know, if the mirrors, if you pass the rays of light, the rays are reflected. But here the rays are refracts. Okay, but here bends. How the rays bends? Okay, now we see one by one. So now this part also almost similar to reflection of light in mirrors, concave and convex. C1, this is C2, okay, and this is optic center. The distance from C1 to O is equal to distance from O to C2, okay, and then you know, so high pass are rays of light. Okay, and passing are rays of light. These rays undergo refraction, and see here. So now these rays are parallel to principal axis. So these rays are meet at one point. Okay. So this point is known as principal focus. Principal focus. Okay. You can ask why these rays are meeting at F2 only. Why the rays are bending like this? Why not like this? Okay, like this. So now here, if you pass a rays of light to convex lens, okay, after refraction, all the rays are meet at one point. meet at one point. Okay, and here so this is F1, F1, F2. Here also the distance from C1 to F1 is equal to F2 to C2. The distance F1 to O equal to O to F2. Why? Because the distance C1 to O is equals to O2 to C2. Okay. Now we can see why the rays are converges at one point. Oh, okay. See here, if you draw a line like this, it will become a circle, right? Okay. Now this portion is a part of this side circle, and this portion is a part of this side circle. Okay. So now just imagine I am passing a ray of light. I am passing a ray of light. This is my incident ray. Okay. In here also we should draw normal from the center of curvatures. Okay. So now I will draw normal. See here. Sorry. See, now this is a part of this side circle, right? So now we should draw normal from center C2. Now see here, this is a normal. Okay. So now our ray of light now traveling from air medium to glass medium. Okay, because this is a lens. Lens is what it is made up of glass, right? So now our ray of light traveling from rarer medium to denser medium. If a ray of light travels from rarer medium to denser medium, how it bends? It bends towards the normal. It bends towards the normal. Why? Because here the speed of light decreases. Okay, so that's why it bends towards the normal. Okay, so otherwise it looks odd. Here. See, now it bends towards the normal. Okay, now it bends towards the normal. Now just observe here. First it travels from rarer medium to denser medium. But what about this side surface? Here a ray of light traveling from denser to rarer. Okay, or emergently we studied the refraction of light in the rectangular glass slab. First it travels from rarer to denser. Once again it should come outside, right? So then in this case here it travels from denser to rarer. So now here also we should draw normal. So now this portion, this surface is a part of this side circle. So here we should draw normal from this side, from center C1. here. Okay, so now ray of light traveling from denser to rarer medium. In this case, the speed of light increases. So that's why it bends to away from the normal. So this is the normal. So that's why it bends away from the normal. It bends away from the normal. Okay. So that's why it will after refraction it will travel through F2. Or if you consider here, okay. So now I will pass a ray of light here. Okay. This is incident ray. So now this portion is a part of this side, right? So now here we should draw the incident ray strikes here. So here at this point of result, we should draw normal from center C2. Center C2. So now ray of light traveling from rarer medium to denser medium. So that's why it bends towards the normal. It bends towards the normal like this. Okay, it bends towards the normal. Now once again here, our ray of light traveling from denser to rarer medium, denser medium to rarer medium. So now that ray it strikes here, right? So now this portion of this surface is a part of this side circle. So here at this point of incidence, we should draw normal from center C1, from center C1. Okay. See now I will erase this one. So now here a ray of light traveling from denser to rarer medium. In this case, the speed of light increases. So that's why it bends away from the normal. This is the normal. If it bends like this, so we can call it as it bends towards the normal. Here a ray of light traveling from denser to rarer medium, right? So that's why it bends away from the normal. Away from the normal. Okay, so that's why all the rays are meet at one point. Okay, see here I am passing a rays of light parallel to principal axis. Suppose I will pass through like this, I will pass through like this, like this. You'll see later. Okay, how the ray after refraction, how the rays are move. Next, this is the refraction of light in convex lens. Okay. So if you pass rays of light to see here, okay, see actually here double refraction takes place. First refraction takes place here and here. Okay, while drawing the diagrams, okay, we won't draw like this. See first we won't show here first it bends here and here. So here directly see at the center. Okay, just we will show that bending of light only once here. Okay, no need to show the bending of light from here and here. Actually, this is the process. Okay, actually, this is what happens in lenses when you pass rays of light to convex lens. But while you are drawing the diagrams, we will draw like this. Okay, so now here this is a convex lens. If you pass rays of light to convex lens, so after refraction, all the rays are meet at one point. Suppose if you pass rays of light to concave lens, concave lens. C2. Okay. Suppose if you pass a rays of light to concave lens, so now here the rays of light diverges like this. Diverges. Here the rays are converges and here the rays are diverges. Okay. Now we will see why the rays are diverges in a concave lens. Yeah. C2, C1. Okay. Now see here. So now this portion it is a part of this side circle and this portion is a part of this side circle. Okay. So now for this surface C1 is the center of curvature. For this surface C2 is the center of curvature. But it is opposite in convex lens here. So now consider one ray of light and passing parallel to principal axis. How to draw normal here? So now this is for this surface C1 is the center, right? So we should draw normal from C1 like this. So now here a ray of light traveling from rarer medium to denser medium. Okay. Now how it bends? So here the speed of light decreases. Why? Because it is traveling rarer to denser. So now here in this case, what the ray bends towards the normal, towards the normal. It bends like this. Okay. So now it strikes here. How to draw normal here? See, for this surface C2 is the center. So here we should draw normal from C2. So now ray of light traveling from denser to rarer. Here the speed of light increases. The speed of light increases. So that's why it bends away from the normal. Away from the normal. Okay. So due to this reason, the rays are diverges in concave lens. Okay. Suppose I will pass a ray of light here. Incident ray. So here we should draw normal from the center C of 1. See, so now here also ray of light traveling from rarer medium to denser medium. Here the speed of light decreases. So that's why it bends towards the normal. It bends towards the normal. So now, so here it strikes here. So here in this case, see, for this surface, C is the center of curvature. Okay, we draw normal from here. So now ray of light traveling from denser to rarer. So here how the ray bends. So now here ray of light traveling from denser to rarer. Here the speed of light increases. So that's why it bends away from the normal. Away from the normal. Okay. So hope you got reason why the rays are diverges in concave lens and converges in convex lens. Okay. So in tomorrow class we'll study if you pass a rays of light to what now we have studied if the rays parallel principal axis it passes through principal focus. Suppose I will pass a ray of light through F1, then I pass a ray of light through C1, then I pass a ray of light through optic center. How the ray bends and how to do, we will study everything in the next class. Okay, thank you.